Hello, you're welcome to this lesson. In this video, I'm going to learn how to find a higher order partial derivative of multivariable functions. So I have the first example here, which is f of xy equals cosine of 2x minus x to the power 2 multiplying exponent 5y plus 3y. So you have to find fss, fxy, fyx, and fyy. So let's look at how we are going to do this. So first of all, to find fss, we must first of all differentiate this whole function here with respect to what x. Okay, so that will be the partial derivative with respect to what x. So let's look at that. So differentiating cosine of 2x, I'll first of all differentiate the whole expression. Okay, so that will be the derivative of cosine of 2x, that will be minus sine of 2x. Okay, minus sine of 2x. Then from there, I will find the derivative of the expression inside, which is 2x, and then that gives us 2. Okay, so then multiply by what? 2. Then minus. Now let's look at what you have here. So over here, I have this term here. Okay, but you see that you have the first one and then you have the second one. The first one is x squared, and then the second one is exponent 5y. You see that for the exponent 5y, there's no x there. Okay, so you can keep it as a constant. Okay, so you will only differentiate this x squared. Then differentiating the x squared will give us what? 2x. So you have 2x multiplying e to the power 5y. And then for the last term, we don't have any x in it. So differentiating it will be like differentiating a constant. So that was 0. So you can have plus 0. So now let's rewrite this. I'm going to have f sub x to be equal to minus 2 multiplying sine of 2x, okay, minus 2x e to the power 5y. So now that's fx. So now you can find fxx, which is the second partial derivative of the function with respect to what? X. Okay, so you're going to differentiate this function here with respect to what? X. So let's look at that. So that gives us fxx. Okay, so let's write the minus 2 and then let's differentiate the sine 2x. Differentiating sine 2x will give us 2 multiplying cosine of what? 2x. Okay, and just like what I did here, so you first of all differentiate sine 2x, and that will give us cosine of 2x, then you multiply by the derivative of cos inside, and that's what gives us this 2 here. Okay, so now let's continue. So minus. Now for this term, we still don't have any x in it, so we are going to keep it as a constant. So now let's differentiate 2x. That gives us 2, so that will be minus 2 multiplying e to the power 5y. So now let's rewrite this. We're going to have fxx to be equal to this 2 multiplying these 2 here. So that gives us minus 4 cosine of 2x. Okay, then we will have minus 2 multiplying exponent 5y. So that gives us fxx. Now let's find fxy. So to find fxy, we come and take this fx function here. Okay, so we have the fx. Let me write it. We have the fx to be equal to okay, so that will give me minus okay, let me write this minus 2 sine of 2x minus 2x exponent 5y. So that's what fx, right? That was differentiating the function with respect to x. So now from what you have here, we are going to differentiate this with respect to what? Y. So let's look at that. So that gives us fxy. Okay. So for this first term here, we don't have any y in it, so we will keep it as a constant. And you know, differentiating a constant will give us what? 0, right? So we have 0 here. Let's look at the second term. So for the second term, you have 2x multiplying e to the power 5y. this 2x doesn't have any y attached to it, so we are going to keep it as a constant. So you have minus 2x. Now let's differentiate e to the power 5y. Differentiating e to the power 5y, okay, I'm going to have e to the power 5y. Then now I'll multiply by the derivative of what? 5y, which is what? 5. So in simplifying this, I'm going to have fxy to be equal to minus 2x multiplying 5 e to the power 5y. So that gives us fxy to be equal to minus 10 minus 10x e to the power 5y. Okay, so this is what you have now. So now let's focus on fyx. To find fyx, you must take the main function. Okay, that's fxy, which is equal to cosine of 2x. Cosine of 2x minus x squared e to the power 5y plus 3y. Okay, so now what you will do is that you will differentiate this function with respect to y. So that gives us fy. Okay, so let's look at that. So for the first term, we don't have y in it, so that would be what is 0. And then for the second term also, we have x squared multiplying e to the power 5y. So we're going to keep the x squared as a constant. So we have x squared here. And then now let's differentiate e to the power 5y. So that gives us 5 e to the power 5y. Okay, then plus the derivative of 3y, which will be what? 3. So let's simplify this. We're going to have fy to be minus 5 f minus 5x squared e to the power 5y plus 3. Now let's differentiate what we have here with respect to what? X. That what? fyx. Okay, so this will be equal to, we only have this term here having x in it, so let's differentiate that. So we're going to have minus 5 multiplying 2x times what? E to the power 5y, which is just a constant in this case. Then for the 3, you don't have any x attached to it, so that was 0. So simplifying this, we're going to have fyx to be equal to minus 5 times 2x. That gives us minus 10x e to the power 5y. Okay, it looks like we got the same answer for fxy. Okay, so now let's look at fyy. So let's consider this function here. Okay, so we have fy to be minus 5x squared e to the power 5y plus 3. Okay, so now let's differentiate this function with respect to y again. We're going to have fyy equals, this is just a constant because it doesn't have any y in it. So we're going to have minus 5x squared. Now let's differentiate e to the power 5y. So that's what? Times 5 multiplying e to the power 5y plus 3. Okay, I first differentiated e to the power 5y, then I multiplied by the derivative of what? The 5y. So simplifying this, we are going to have fyy to be equal to minus 5 times 5, that gives us minus 25. So you have minus 25 x squared, okay, multiplying e to the power 5y. And then for this term, it doesn't have any y attached to it, so that was 0. So I can write fyy to be equal to minus 25 x squared e to the power 5y. So that's all for this question. Let's take another example. So I have this function here, f of xy equals 5x to the power 8 multiplying y to the power 213 plus ln of x plus e to the power xy. So you have to find fxx and then fxy and also fyy, and then for the d, that should be fyx. So now let's look at the first one. So let's find fx first. So we're going to differentiate the function with respect to what? X. Okay, so you have 5x to the power 8 multiplying y to the power 213. So for the first term, we're going to keep this as a constant. Okay, so we're going to have the derivative of 5x to the power 8. Okay, so for that I have 5 multiplying 8x to the power 7. Okay, then let's bring the y to the power 2 and 3, which is just a constant in this case. Okay, so from here, let's find the derivative of ln of x. So for that would be x prime divided by what? X. But we know x prime is what? 1, which is the derivative of x. So we're going to have 1 over x. Okay, then plus e to the power xy. So that gives us e to the power xy. Now let's differentiate xy with respect to x. That gives us what? Y. So that will be times what? Y. Okay, so this is what you have. So in rewriting this, you're going to have fx to be equal to 5 times 8, which will be 40. So you're going to have 40, you're going to have 40x to the power 7, okay, times y to the power 2 on 3. Okay, then you will have plus 1 on x, and then plus y multiplying e to the power xy. Okay, this is what you will have. And then from here, what I want us to do is let's find fy at once. Okay, so let's look at that. So from the function, you have the first term 5x to the power 8, which will be a constant in this case. You're going to have 5x to the power 8. Now let's differentiate y to the power 2 on 3. Okay, so differentiating this, you're going to have times 2 on 3. Okay, multiplying y to the power 2 on 3 minus 1. Okay, and then plus. For the second term, you don't have y in it, so that was 0. And then for the last term, we're going to have plus e to the power xy. Now let's differentiate xy with respect to what? Y. That gives us what? X. We will have times what? X. So now let's simplify this. So you're going to have, let's first deal with this power that you have here. So 2 on 3 minus 1, that gives us minus 1 on 3. Okay, so let's take note of that. So I'm going to have 5x to the power 8 multiplying 2 on 3 times y to the power minus 1 on 3. Okay, plus x multiplying e to the power xy. Okay, so now let's simplify this. So we are going to have 5 times 2 on 3. That gives us 10 on 3. So we're going to have 10 on 3 multiplying x to the power 8, and then y to the power minus 1 on 3. So y to the power minus 1 on 3. Okay, so let's have this here, then plus x e to the power xy. So now let's take note of this too. So we have, let me circle this. We have this. Okay, that was wrong. Okay, so you have this expression, and then you have this expression. So you are going to build up on these two derivatives that you have derived here. So now let's continue. So from here, let's find fxy. So we already have fx. Now let's find fxy. So I'm going to differentiate this function here with respect to what? Y. So that will be, so for the first one, which is 40x to the power 7, we are going to keep that. Okay, so that will be 40x to the power 7. Now let's differentiate the y. Okay, that's y to the power 2 on 3. So that will be 2 on 3. Okay, multiplying y to the power 2 on 3 minus 1, which will give us minus 1 on 3. Minus 1 on 3. Okay, plus for the second term, we don't have any y in it, right? So let's make it 0 because it is a constant, so that will be 0. Then plus for this one also, we're going to differentiate it with respect to what? Y. I'm going to differentiate all this term with respect to what? Y. So we are going to apply chain rule here. Okay, so we are going to have something like y multiplying e to the power xy. So first of all, I'm going to differentiate this and then keep this as a constant. So differentiating y will give us 1. So you have 1 e to the power of xy plus, and then now I'll differentiate this term and I'll keep this as a constant. So we are going to have y multiplying e to the power of xy. They are going to differentiate this xy here with respect to what y, then that gives us what x. So we're going to have times x. So we're going to have e to the power xy plus xy e to the power xy. Okay, this is what you will have. So let's write this here. We're going to have plus e to the power xy plus xy e to the power xy. Okay, this is what we have now. Okay, so now let's simplify this. F, we're going to have fxy, okay, to be equal to, so 40 times 40x to the power 7 times 2 over 3 y to the power minus 1 on 3 will give us 80 on 3. Okay, 80 on 3 x to the power 7, and then multiplying y to the power minus 1 on 3. Okay, then we are going to have plus e to the power xy, okay, plus xy multiplying e to the power of xy. So that's what the value of what fxy. So now what we need to find now is fyy, right? So now let's consider fy here. So now let me free up some space. So you can try this on your own so that you compare the answers you get at the end. Okay, so now you have fy. So now let's differentiate it with respect to what y again. So we are going to have fyy, and then for the first term, okay, I'm going to keep the 10 on 3, okay, x to the power 8 as a constant. So we are going to have times minus 1 on 3 multiplying y to the power minus 1 on 3 minus 1, okay, and then plus, I'm going to keep this x as a constant. Okay, so I'm going to have x and then multiplying the derivative of what e to the power xy. So that gives me times e to the power xy. Then I differentiate this xy here with respect to what y. So that gives us times what x. So now let's simplify this. I'm going to have fyy to be equal to, we have minus 10 on 3, sorry, 10 on 3 multiplying minus 1 on 3. Okay, so that gives us minus 10 on 9. Okay, so minus 10 on 9 x to the power 8, and then y to the power, we have minus 1 on 3 minus 1. So that gives us y to the power minus 4 on 3. Okay, now let's look at what you have here. So we're going to have plus this x here times this x will give us x squared e to the power xy. Okay, so that should give us our answer. So now let's find the last one, which is fyx. Okay, so now let's find fyx. Okay, so we have fy here. So now let's differentiate it with respect to what x. Okay, so we're going to have this to be equal to, I'll take this first expression here. Okay, so that will be 10 divided by 3. Okay, now differentiate x to the power 8. That will be 8 multiplying x to the power 7. Okay, then for the y to the power minus 1 on 3, that will be treated as a constant. So we just write it there. So that will be y to the power minus 1 on 3. So plus, let's look at this term here. We're going to differentiate with respect to what x. So I have x multiplying e to the power xy. So now let's apply the product rule here. So I'll first of all differentiate this x and then keep this term. So we're going to have the derivative of x to be 1. So we have 1 multiplying e to the power xy. Okay, then plus, I'll now keep x and then I'll differentiate e to the power xy. So that gives me e to the power xy, and then multiplying by the derivative of what xy with respect to what x, and then that'll give us what y. So then we are going to have e to the power xy plus xy, okay, multiplying e to the power xy. So now let's substitute this here. We're going to have plus e to the power xy plus xy. Okay, plus xy multiplying e to the power xy multiplying e to the power xy. So that will be for fyx. So you can also try and find fxx. Okay, thank you very much for watching this video. Please make sure you like and subscribe.